Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2020 on Joule-Thomson coefficient. The question is, for an ideal gas, the value of Joule-Thomson coefficient is, options are 0, indeterminate, negative, positive. Now my dear students, Joule-Thomson coefficient is represented by mu, and it is nothing but temperature, pressure, behavior due to throttling. Now my dear students, throttling is nothing but constant enthalpy process, and due to this throttling, if I drop temperature on y-axis and pressure on x-axis, then I will get some graph like this, and the slope of this graph is called Joule-Thomson coefficient. Whatever may be the slope of this graph is called Joule-Thomson coefficient. Therefore, slope is nothing but change in y coordinate divided by change in x coordinate, which is nothing but change in temperature with respect to change in pressure due to throttling, means at constant enthalpy. Therefore, this Joule-Thomson coefficient is called change in temperature with respect to change in pressure at constant enthalpy. Now they are asking for ideal gas. They have mentioned here for ideal gas. Now my dear students, for ideal gas, enthalpy is nothing but CPT. H is equal to CPT. And my dear students, for ideal gases, Cp is constant. Cp is always constant. And if enthalpy is constant, then temperature is also constant. Right? For ideal gases, Cp is constant, and for throttling, enthalpy is constant. Therefore, temperature will be also constant. That means we can say change in temperature is 0. And as for ideal gases, change in temperature is 0. Therefore, mu for ideal gases will be equal to 0 divided by dP, which is nothing but equal to 0. Therefore, the Joule-Thomson coefficient for ideal gases will be 0. That is, option A is the correct choice. Now, the next question was asked in GATE 2020. This question is, for an ideal gas, again they have mentioned here ideal gas. That is, ideal gas equations are valid. The constant pressure line and constant volume line intersect at a point in a temperature versus entropy diagram. Let us say we have one temperature versus entropy diagram. Temperature versus entropy diagram. On this diagram, we have constant volume line and constant pressure line, and they are saying that intersect at a point. Let us say we can say there is a constant volume line like this. Let us say this is a constant volume line 1 to 2, right? And 2 to 3 there is a constant pressure line. 2 to 3 there is a constant pressure line. Generally, the slope of constant volume line is more than slope of constant pressure line on TS diagram. Here you can see the constant volume lines will be having more slope as compared to constant pressure line on TS diagram, right? Now my dear students, generally if you see dual cycle, in case of dual cycle, the heat addition is at constant volume followed by constant pressure, right? Then read the question. For an ideal gas, the constant pressure line and constant volume line intersect at a point. Here at point 2 they are intersecting in a temperature versus entropy diagram. Cp is a specific heat at constant pressure and Cv is specific heat at constant volume. The ratio of slope of constant pressure and constant volume lines at the point of intersection is. Now they are asking what is the ratio of slope of constant volume line. That is, the slope of constant volume line is nothing but dt by ds of constant volume line, and the ratio of dt by ds of constant pressure line at point 2 is, right? Therefore, they are asking the slope of dt by ds. Very first, the ratio of slope of constant pressure line. They are asking what is the ratio of slope of constant pressure line divided by dt by ds of constant volume line, right? This question is there. Now my dear students, during constant volume process and constant pressure process, what is the heat? Very first point, for constant volume process, the heat is nothing but dq is nothing but internal energy that already you have seen in first law of thermodynamics. Therefore, heat is nothing but TdS and internal energy is CVdT. Therefore, for constant volume process, dt by ds for constant volume process is nothing but P by Cv. This is the slope of constant volume process on temperature versus entropy diagram, right? Again, for we can say for constant volume, for constant pressure process, the slope is, the heat is nothing but enthalpy. Second, for constant pressure process, heat dq is nothing but enthalpy dH. Therefore TdS is equal to Cp dt. Therefore dt by ds for constant pressure process will be equal to T by Cp. This is the slope of constant pressure process on temperature versus entropy diagram, and they are asking what is the ratio of slope of constant pressure line to the constant volume line on TS diagram. Therefore, my dear students, if I find this ratio, that is, the question is here dt by ds at constant pressure divided by dt by ds at constant volume, this ratio. Therefore, this ratio will be equal to T by Cp divided by T by Cv, T by Cv, right? Therefore, this Cv will go up, temperature will get cancelled, it will become Cv divided by Cp. Therefore, look at the option, you will find that option A is the correct choice. Thank you, dear students. In next lecture, we will see one more numerical on this topic.